Hey everybody, we already got some minutes in A3, so I'll just try to add a few more here for some learning to happen today. Hopefully you get some rest and relaxation, and try not to make it too long so that we don't amplify required screen time, of course. Well, a few things I just wanted to highlight. So again, we've got log written this way without a base is so let's say the log of 100. What that really means is log base 10 of 100, and we call this a common log. So anytime you just see log without a base, it's base 10. What power of 10 gives you that number? So this would be 2, because 10 to the second. Okay, and now we learn about this other type. For instance, let me do a little bit funky one. So there's no base here. This is just the natural log of e to the third. So that means, though, log base e of e to the third. Sometimes you'll put the input in parentheses just to clarify that the cube is part of the log and not coming after. Although I think, yeah, not the whole log cubed, for instance. And this is called a natural log. And as I said, anytime you see natural, think E for Euler's number. Euler, again spelled this way, which is the name of the mathematician. And the funny thing about E, it's actually apparently, like we saw in the video, it wasn't named after Euler, but just the paper that he introduced E in, it was like the 5th letter that came up in his paper. So it just was a coincidence that it's E. A nice coincidence, though. And one other thing I'd like to just highlight here is that so you can evaluate these in your calculator. For instance, if I want to find the log of 8 or the log of anything, I don't have to use the table like the mathematician in the video did. I could just do log of 8, enter. What power of 10 gives you 8? And because 8 is less than 10, it's a decimal less than 1. What if I wanted to find the natural log of 0.3? What power of e gives you 0.3? Well, that would be the negative 1.203972804 power. Okay, and these are approximate because these are likely irrational, perhaps going on forever. So let's keep it moving on here. So what I'd like to show you just as the last thing here today, again, keeping it short, is how to use a logarithm as an inverse operation in the same way you would use subtraction to undo addition, for instance. So let me give you an example here, because a logarithm is the inverse of exponentiation, just like subtraction is the inverse of addition. Exponentiation. So if I have something like this, where I have 10 to the log four power, well, this is a funny question because it's saying what power, this log is saying what power of 10 gives you 4. So this is telling you what is the exponent of 10 that would give you 4. And then we're actually putting 10 to that power. So if we're saying this is the exponent of 10 that gives you 4, and we're putting 10 to that power, it is just going to be 4. These are inverses. So the log of the base with the same base of the exponentiation, if that ends up in the exponent, it just leaves you with the input of the log. Let's look at a similar but different example, like log base 5 of 25 to the x. So this one's a bit trickier because the bases are not the same. But what we could do is we could think about, well, 25 could be written as base 5. Check it out. This could be at 5 squared to the x And a power of a power we could multiply, so it could be log base 5 of 5 to the 2x. Now, let's look here. It's saying what power of 5 gives you 5 to the 2x? Wait, are you serious? Power of 5 gives us 5 to a power? Well, it would just be the power, right? 5 to the 2x would give me 5 to the 2x. So once again, it undoes it. So these are the last thing I'll show you is these are the rules that correspond to these inverse properties. If I have g of f of x, like a function inside of a function, kind of like this. Well, let me actually rewrite it this way. Sorry about that. If I have, for instance, log base b of b to the x, that's always just going to be x. Those inverses undo one another. And the other thing we just looked at is if I have, as in this first example, if I have b to the log base b power of x, that is just going to leave me x. So these are just like we could have addition undo subtraction and subtraction undo addition. We could have logarithms undo exponentiation and exponentiation undo logarithms to get you just to the exponent or the input of the exponentiation or the input of the logarithm by itself. Check these out. I'll post a few practice problems and hopefully you can do them in the textbook to avoid some screen time. Maybe I'll do the monitored progress so you can watch those videos if necessary. All the best, Mr. Tanny.